Hello everyone, my name is Chris, and today we are doing something a little bit more interesting. I'm joined by my friends Lauren and Sean, and we're going to be building up some XRPs from scratch, meaning we don't have any instructions in front of us, and we have no idea what we're doing, and we're going to just try and hope for the best, and see how long it takes. We're going to have a running clock to see which one of us finishes first, second, and third. And then when we're all said and done, Engineer Dryw is going to come in and either judge and or critique us.
Yeah. Hands on box.
Hands on box.
Hands off box, actually.
Hands off box.
All right, 3, 2, 1, start.
Well,
already making mistakes. I love it.
You're the amount. Oh shit!
It rolled right over. What was I gonna do?
Leave it alone?
No.
Clearly not.
But it's the spirit of competition.
Yeah. I know. I understand.
I'm gonna throw some trivia at you. Sean, what does XRP stand for?
Experiential Robotics Platform.
Have you ever assembled these before?
Like a year ago, I assembled one because I was a hand model.
Doing what?
Hand modeling. Like in
It's important work, okay? Lauren, name all of our partners of the consortium. That's a great question.
WPI, 3D Printing Nerd, Cornell Engineering Systems.
DECA, Cornell, Experiential,
DigiKey.
First, ST, Microelectronics, Raspberry Pi, University of Idaho, DigiKey, ARM, 3D Printing Nerd, Dagu, and of course
Great.
us.
Keep them distracted.
Hey, you know what? That's actually a really good point. I shouldn't have done that, huh?
Hey Chris, how far are we from the sun?
1 astronomical unit. I'm not wrong.
Who feels the most confident in their build?
I was, until they immediately started messing with me.
No rules.
Someone's
Yeah.
gotta do it. Sean, when did the beta version first come out?
I want to say August 2023.
I don't actually know if that's right.
Sounds right.
Lauren, which state has given every student an XRP? New Hampshire. Very good.
Wow. That doesn't sound good.
Chris, do you know what Rob made for the drawing challenge in the video?
A robot?
Nope.
Oh.
What did he draw?
Oh, so he did make a robot?
No.
Okay.
Well, he made the XRP, but what did he draw?
Oh, the SparkFun flame.
No, that was Dryw.
A Triforce.
Good guess. It was an infinity sign.
Oh. I can read labels, yes I can. I'm not gonna lie. I've taken apart the motors and wheel assembly, I think 3 times now, because I keep getting ahead of myself.
You know what would be so helpful? An assembly.
Yes.
It was really good.
I'm not confused. I'm just figuring it out.
Oh! Oh! Lauren's time. 11:58.
None of this is right, probably.
Yeah, are all your wires in the right
But
spot?
she looks pretty.
That's right. Alright, Lauren, hands off it. Done.
I've got another 5 minutes probably. We're making progress.
Well,
Done.
alright!
Alrighty, I was brought in to judge some building, I guess. So we're gonna take a look at these XRPs. I do like the stickers. One of you did not put stickers on. I'm very disappointed. First, okay, actually, I want to judge the stickers first because I've not actually really done stickers much myself. I like the little flames on the side. You're covering up some of the logos though. I gotta take off points for that. Don't like the logos being covered up. The star is cute, little arrow, enjoy that. Ooh, debug duck, appreciate. I think in terms of looks, winner has to go to this one. I like this one felt like too many stickers and you're covering up logos. This one didn't have any stickers, disappointing. Good balance, good use of flames. I appreciate it. Let's see, other things to look at. Cable management, and also the line following sensor is not in the middle. That's going to be a challenge to follow the line. Oh, and also this motor is actually not snapped in all the way. I need to push on those in order to get those snapped in. In fact, I'll do little snap there. That's what you need to make sure the motor's in place. So point knocked off for the motor not being in place, and poor cable management. This line sensor is even further off from the center. None of you put your line sensor in the center. How do you expect to follow a line if it's not in the center? I mean, you can do it, but... yeah, cable management. I think all of you get a fail. So wait, hang on. This is routed through the marker holder. The marker is meant to go through there. That's hilarious. How did you? Okay, yeah, there's a little slot right here that the cable's meant to go through. So for the barrel connector for the batteries. In fact, two of you did that. Okay, I think cable management. This one gets a win just because they're all unmanaged cables, but this one did not. This is the only one that routed the wire through the right spot. That's hilarious. Let's see, I see, okay, this servo is actually centered. Let's see what range of motion is. The range of motion isn't quite set all the way. Usually when it's in the sort of index in the right position, it actually goes down to more of kind of like downwards angle. So, but mostly centered. Other than that, this one's off center, which is fine. Plugging it in can be a little tricky. Although the arm is actually in the wrong orientation. See on this one, the finger of the hook is kind of up like this, so you can actually grab something. This one, not gonna grab anything, and it's gonna slide off or something like that, so there's a couple notes there. This one got it correct as well. And also off-centered, totally fine. USB cable can be a little tricky to plug in when it is centered. So you'd be like, reaching around stuff, it's a little tricky. So understand it not being centered. Don't understand the line sensor being off-center. Let's see, other than that, I mean, ultrasonic sensors are all in the right places. You put a sticker over the ultrasonic sensor. Oh, geez, we'll see what that does for its measurement capabilities. It might be fine, I'm actually not sure. We can look at some of the wiring. Let's see, you've got the motors connected in the right spots. Yeah, so all you got the motors in the right spots, which is good. This one, the line sensor is plugged into the Quick 1 connector. The one right next to it is labeled line. Let's see, ultrasonic distance is the right, yeah, okay. Oh, yikes, this one, okay, you got the line sensor in the right spots. The ultrasonic sensor is also in Quick 1, should be in the one labeled distance for ultrasonic distance sensor. And also you didn't take up all the Kapton tape off of the connectors. So that's fine, other than the connector's in the wrong spot. The order of the wires, this one's a little tricky because black to ground and red to power, that's very standard. Most people, I think, know that. And we'll just double check. Yeah, your ground and power in the right spots on this. ground and power in the right spots there. Yeah, you got your ground and power and ground and power. Ground power, ground power. Okay, all you did get the black and red wires in the right spots. Good job. I'm proud of you. The two data wires, the blue and the yellow wires, those ones are a little easy to flip. My helpful mnemonic that I like to think of is that the black and yellow go next to each other like the stripes of a honeybee, because then it just goes black, yellow, blue, then red for both the sensors. On this one, got black, then yellow, blue, red. Black, yellow, blue, red. Excellent. Other than the ultrasonic distance sensor being plugged in the wrong connector, the wiring is all correct there. Oh yeah, also the orientation of the servo connectors. I'll do that in a second. Black, blue, yellow, red. So the ultrasonic is wired flipped on this, but the line sensor is correct. And then on this one, again, ultrasonic, wrong order of the data wires, and also on the line sensor. Okay, so I think for wiring accuracy, so this one got it correct for the two sensors, which is good. This had one flipped, this had both flipped. Interesting thing about the flipping is that for the line sensor, if you flip the two, then just flip to the left and right, that's not a huge deal. For the ultrasonic sensor, it actually does make a bigger deal because one of them is like a trigger pin of like, hey, send a command to actually send out the pulse to read it, and the other one's actually the receive pin or the echo pin. So that will affect the functionality of the ultrasonic sensor for these two. They just won't get any data, so you have to flip those. The servo, let's see, all of you are plugged into servo 1, which is good, and you got the orientations all correct, and it looks like all the pins are in the right spots. They're not like offset by 1 or anything like that, so that looks pretty good. Let's see. Checking some other little fit and finish. Got the caster wheels all in place, which is good. The battery holders and little support bars are in, which is all good. No batteries installed, but that's fine. Wheels are all assembled. It looks like all of the motor cables are plugged in. All the motors spin freely, which is good. Yeah, okay, I would say, okay. On the whole, I think just looking at it overall, this one's probably the winner of, without having tested anything, in terms of the assembly accuracy and the aesthetics of where the stickers are placed and everything. The biggest problems on this is definitely that the ultrasonic sensor is plugged into the wrong connector, and the battery power cable is routed through the marker holder. And think in terms of functionality, it's kind of, This one does have one of the the ultrasonic sensor data wires flipped, but the connectors are in the right spots, and yeah, everything was in the right place. This one did have that loose motor, and the connector for the line sensors in the wrong spot, and the data wires were flipped. Well, this one did also have the flipped servo arm, but that one's kind of minor. I think I'm going to have to give it, in terms of just like visual inspections, first, second, third. All right, we got all these boards updated with the latest MicroPython and XRP lib. We just did the off camera just to get things rolling here. Got this robot all set up, and so we'll go ahead and connect to that. And this actually has some other code on there that was being messed around with before. I'm gonna open up the installation verification, and we're gonna give this a run to see if everything is all happy. And certain things, I know some things won't be. All right, so we do have the blinky blue LED, like we expect, and I'll go ahead and press the user button, and it will start testing the line following sensor. And as I move my hand under the line sensor, nothing changes, and that's because the sensor is plugged into the wrong connector. So I will go ahead and unplug that and put it into the correct connector. Ah, there's some bent pins in here. I wonder if that's why it wasn't plugged into here. Is that why I didn't plug it into here? Yeah, okay, we'll just say that is a no, that is not a pass on the line sensor. We'll just move on to the next part. The ultrasonic sensor, put my hand in front of it, and we are not getting anything. Again, that's because the two data wires are flipped. So what I'm gonna do is actually just quickly, actually one more quick comment while I notice it. The ultrasonic sensor on this is actually not fully inserted into the mount. On the side here, it's like not fully grabbed onto the board. Just need to push a little bit more for that to snap into place. But I'm going to remove that real quick so I can flip those two wires. Flip those around. So we get the blue goes next to the red, the yellow goes next to the black. And hey, look at that, we're getting some data from it now. So I'll go ahead and put this back into the mount. And if I put my hand about this far away, it's measuring about 10 centimeters. Put it this way, about 20. So ultrasonic sensor is working. Press the user button again, and now it's going to test the servo. There's no batteries installed, but I do have the USB cable powering the board and the power switches on, so it should still work. So I will go ahead and push this button, and we'll see the servo move around. Now a couple things that happened there. One is that the indexing of the horn into the servo is not in the right spot, so it actually ended up ramming the arm into the chassis. The second thing that happened, it actually popped out of the mount because it was not fully seated in the mount. In fact, it was mounted backwards. I just noticed that. It was this way. It's meant to be this way for the servo. There's a couple little nubbins right here that grab the little wingy parts of the servo. So the servo is kind of upside down there. But we'll just leave that sitting on top. We'll go ahead and do the last test, which is testing the drivetrain. Also test the motors, which are working. Yay, well done. I don't have quite enough room on this table here. And then it will turn. A little bit of overshoot there, but that's fine. And the motors are connected, barring the assistance that I did of actually snapping the motor back into place. So had some issues with the servo and the two sensors, and also one of the motors not being in the right spot. But other than that, we do have a functional robot. It can do some things, drive around and do some other things like that. Move on to the next robot. Go ahead and plug in that cable. And we are connected. We'll go ahead and run the installation verification again. Flip the power switch to the on position. And run that. And then give that a moment. All right, we got the blinky blue LED, which is good. Go ahead and press the button to start testing the line sensor. Now this one, we move our hand in front of it, we do get changing values. Wonderful. Are they correct? If I put my finger over to the left one, can see the left values changing, which is good, and the right one, the right value changes. So the line sensor is fully functional on this one. Wonderful. Press the button to test the ultrasonic sensor. Again, same thing, the data wires were flipped. It does look like it is fully in the mount this time, so that's good. So we'll go ahead and pop that out, and we'll just flip the two wires for the yellow and the blue. Just pop those out. Again, yellow goes next to black, like the stripes of a honeybee, and the last spot for the blue wire is the other connector. And we're getting some data from that. Go ahead and snap that back in. Now with the sticker on here, does this actually work? It does. That's fascinating. All right, yeah, we're going about 10 centimeters, 30 centimeters. Move my hand a little further. So, all right, apparently you can put a sticker on your ultrasonic sensor and it will still function. Don't know how well it'll function. Might be a little degraded on some situations, but it can be done. All right, we'll test the servo on this one. Go ahead and press the button and we'll see that move around. Ooh. And the servo did not like that. I'm actually going to unplug that real quick. It was, again, because the indexing of the servo is not quite in the right spot, it was trying to ram the servo arm into the chassis. So I'm just unplugging it just to make sure the servo is not stressing itself. And then we'll go ahead and do the last test of the drivetrain. Motors are working, which is wonderful. Turns the right amount, a little bit of wobble. That can happen sometimes, depending on what surface you're on, and it comes back. Only problem on that was the ultrasonic sensor wires were flipped and the servo was in the wrong index. All right, and then the last one, we'll plug that in. We are connected. Go ahead and run. Make sure the power switch is on. And give that a moment to initialize everything. Ooh, we do have a minor issue. Yes. So I'm getting an error message in XRP code about error timeout. It's a little bit of a obscure error. What this is actually saying, you can see the file is part of imu.py. That actually indicates there's a problem communicating with the IMU. The reason for that is because the ultrasonic sensor is actually plugged into the Quick 1 connector, and the two data wires the IMU is expecting them to be I squared C, the ultrasonic sensor is expecting them to be a trigger and an echo. So they're completely different things. And they're sort of conflicting with each other. So that's actually causing problems with communicating with the IMU on the board. My bet is if we unplug the ultrasonic sensor and then hit the run button again, then it should just work. Yep, now it's initialized properly. That IMU communication has been established. What I will do is remove the Kapton tape from the distance sensor, and we'll go ahead and plug that into the correct connector this time. There we go. And we do have the blue blinky LED, which is wonderful. Going to press the button, and we're testing the line sensor. Move my hand, I get some data. Left side is the left side, and the right side is the right side. Wonderful. Press the button again to test the ultrasonic sensor. Now that it's in the right spot, I am actually getting some data from it, and it looks correct. Again, 10 centimeters, 20, 30. Wonderful. We will then test the servo. So let's give that a second to go. Yep, it's moving. It is trying to ram itself into the control board again because that indexing is in the wrong spot, but that's okay. I'll just unplug it just to make sure it's not hurting itself. I mean, to fix that is really easy. You can just pull this off, plug the servo back in so that it's going to its target position, and then I think it's meant to be sort of in the forward position here, and now it's not ramming itself into the control board. And the last thing is testing the drivetrain. So we'll press that button, and it moves forwards. It turns, a little bit of wiggle again, and comes back. Wonderful. So we've definitely got a few minor issues here and there, but like on the whole, these are actually assembled almost fully correctly. Like, it's just a couple minor issues, really easy things to fix, and you can see just how quickly I was able to fix some of these things. So, yeah. I think in terms of giving a grade for these. Ooh, there was definitely some issues. This one had the flipped wires. The servo, I noticed, was in the wrong spot, and the ultrasonic sensor was not actually fully in the mount. This one did have one flipped wire. The sensors were plugged into the correct ports, which is good. All of these had issues with the servo not being indexed in the right spot. Again, that's a really easy thing. This one, the sensors were wired correctly, except for the fact that the ultrasonic sensor was connected to the wrong connector. But on the whole, I mean, the core features all worked on these boards, especially the motors they all drove. I think on the whole, both phases of the testing, I'm gonna have to say first, second, third place.
So to put this together a little bit better and a little bit faster, make sure you read the assembly guide or check out the video. We have a full assembly guide video starring Drew that will help you out every step of the way.
Mr. Goodwill Hunting. Magnus.
Should I give context?
Hey, hi.
Is that where it's supposed to go? No, that's too low.
No, I can't.
Oh, Chris, what did you learn?
I learned all about holes.